Hey everyone, Mr. Armitage here. In this video, we're going to be going over a quick example to try to help you with constructing a confidence interval for a population proportion. Okay, so here's our example. Right, the Health, Behavior, and School-Aged Children Network collects data on various behaviors of preteen and teenage children. In 2016, the HSBC network surveyed a randomly selected sample of 1,661 preteen and teenage boys in Hungary to determine what proportion of students were bullied at least twice per month in the previous few months. In the sample, 104 students were bullied at least twice per month. The HSBC network wants to construct a 95% confidence interval for P, the proportion of preteen and teenage boys who are bullied at least twice per month in Hungary. Okay, now we could go through identify population, identify the parameter, okay, identify the sample, identify the statistic, see if we meet the three conditions. That's a separate video. That's a separate concept. Here, we just are calculating the confidence interval. Okay? So first thing that we need for our confidence interval is our sample proportion. Now our sample is 1,661, and in that sample, right, 104 students are the ones we are interested in. Okay? So we have 104 out of 1,661. Okay? Now, we don't actually need to convert this into a decimal. We can leave this as a fraction just fine. We'll work with it. Okay, so then from here, we want to calculate the standard error, which remember is the same thing as the standard deviation, but using our sample proportion. Okay. Now we have all of these numbers. So, okay, 104 out of 1,661 times 1 minus 104 out of 1,661 divided by 1,661. Okay. This one, sure, why not? Let's convert these to decimals, okay? But whenever we want to, or sorry, whenever we do a calculation, we should leave it as the fraction until the very end. Okay? So 104 out of 1661, 0.0626. Okay, this standard error of our sample proportion is going to be, let's see here, store 1 minus 0.005944. Why'd I go that far? I don't know, because, okay, it's more decimal places than what we had here, what we had for the proportion, so it's probably good. Okay, now 95% confidence. Okay, that means that our value of z star is going to be 1.96, right? Consult the lesson on March 14th for how to find the value of z star for a particular confidence level. Or there might be another video on that too. Okay. Now that we have that, okay, every confidence interval is always going to be some sort of point estimate plus and minus the margin of error. Okay. Now the margin of error is z star times the standard error in this case. Okay. So our point estimate is p hat. Okay. So we have p hat times, or sorry, p hat plus and minus z star times our standard error. So our p hat 0.0626 plus and minus z star 1.96 times our standard error 0.005944. Okay, simplified again a little bit. 0.04. Our margin of error becomes 0.01165. Okay. So now this is going to split up into two numbers, right? A subtraction and an addition, because that's what it is. Okay. So we have 0.0626 minus our margin of error and our 0.0626 plus our margin of error. Okay, so 26 minus 0.01165. Okay, this becomes 0.05095. And the addition part becomes 0.07425. Okay. So round it, since we only did since we only did 4 decimal places for our proportion. There we go. Okay. Let's go ahead and we get 0.0510. Okay, rounded 4 decimal places. 0.0743. Okay, so this is our confidence interval. So this is telling us, okay, we are 95% confident that the interval from 0.0510, why not, to 0.0743 captures the true, now this is the important part, because this comes from the description of the problem, because we need the parameter, the true proportion of preteen and teenage boys in Hungary that were bullied at least twice per month. Okay, unfortunately, very often the description of the parameter is just as long as anything else in the problem. But there we go. Calculation of our confidence interval.